Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 25, volume 8, surface area. Okay, so in this problem here, I've decided to bring in a little bit of a visual aid, if you will. This is called a net. So whenever you cut a box apart and it falls apart, the bottom is right here. That would be the base. This side is the front. The side you can't see over here is the back. This face that's facing us would be laying right here. The back we can't see is here, and this is this gray top. Okay. So this is saying what is the surface area and volume of this right rectangular prism. Okay, so a lot of students don't read directions, and this is asking for two things, so we need to do both. So to start off, I brought in this net to explain these pieces, and I'm going to write all the lengths down. So I know that this is 11, so this is 11, this is 11. I can't see that. Let me change to black. This is 11, this is 11, 11, 11. The length does not change anywhere on the box. The height is 10. So the height is this piece here. That's the front, and the back is here. So that's 10. So we know the length and the width of the face is 11 by 10. The height of this gray piece, the length is 11, but it's only 6.5 inches, and that's my top. So that's here. So this would be 6.5 inches. And I haven't been writing inches here, but you get the idea. Okay, so that's 6.5 inches. And the bottom is also going to be 6.5 inches. So this is 6.5 inches. And then finally, the height here is 10. So this is also 10. So if I folded this up, it would match this here. So this 10 and this is 10. That'd be this edge right here would be right here. Okay, just picture this being a little bit bigger. It doesn't seem to fit properly, but this gives the idea. So this is also 10 here. It's the height of the box by the 6.5 inches. So this is 6.5. Okay. So we know that volume. Let's do surface area first. We know that the surface area of a prism, rectangular prism, is all 6 sides added up. And we have length times width multiple times. And the front and the back are equal. So if I call the front length times width, there are 2 of them. That's the front and back. And I'm just going to mark those FB plus. And then let's do left and right sides. So the left side and the right side are 10 by 6.5 and 10 by 6.5. There are 2 of them. So I'd say 2 length times width of those. And then finally we have front, back, left, right, and then we have top and bottom. And we have 2 of those, the top and bottom. When we look at the top, it's 11 by 6.5, and so is the bottom. So that's going to be another length times width. So it's rewritten a better way, I suppose, would be length times width times height. But I'm just going to leave it at this for now. So I'm going to plug in my givens. So the length and width of the front and back, which would be F and B, would be 11 by 10. Plus 2 of the left and rights. 2 of the left and rights, this is left, this is right, are 6.5 by 10. So 6.5 times 10 plus 2 of the top and bottom. This is back and bottom. So top, bottom are both 11 by 6.5. So there's 2 of them. 11 times 6.5. Okay, so the surface area is going to equal 2 times 110 plus 2 times 65 plus 2 times 6.5 times 11 is 65 plus 6.5, which is 71. Multiply these by 2, and 2 times 110 is 220. 2 times 65 is 130. 2 times 71.5 is 143. So the surface area is all of these added up. 220 and 130 is 350, 450, 493. So I have 493 inches squared. And that is my surface area. Okay? Alright, so I'm going to erase this. So if you need to see this for any more for this period of time that we've had, pause the video. So I'm going to do volume. Okay, so now volume equals length times width times height. Now volume's easy. Volume equals the length, 11, times the width, 6.5, times the height. Actually, let me do it correctly. With unit of measurement. Length is 11 inches, and we're going to multiply that by the width. Width is 6.5 inches, times the height, which is 10 inches. So the volume equals 11 times 6.5 times 10. Okay, so 11 times 6.5 times 10, 750 inches cubed. Okay, now I got a little bit more specific with the surface area there. I wanted to show it as a net to explain that there is a front and a back you can't see, and a left and a right you can't see, and a top and a bottom you can't see. Okay, so moving on to example 1. Jay has a small fish tank. It is the same shape and size as the right rectangular prism shown on the opening exercise. Okay, so it's the same shape and size as this. Okay, so I'm going to leave this in view. Okay. The box it came in says that it is a 3-gallon tank. Is this claim true? Explain your reasoning and recall that 1 gallon equals 231 cubic inches. Okay, so we just figured out the volume of this, and we got 715 cubic inches. So in order to prove this is true, I have to convert the cubic inches to gallons. Okay, so, one moment. Okay, so I brought this measurement in from Google, and it says volume, 1 US liquid gallon is equivalent to cubic inches, 231. See how much more difficult this is than metric? 1,000 cubic centimeters is 1 liter. Nothing to memorize, you just have to know 10, 100,000. This one here, 231 cubic inches in a gallon. Okay, oh, and it does say that right here. It says to recall it. Okay, so I recalled it. So let's move on. It's the same shape and size as the right rectangular prism, and now we want to prove that this is true or not on the labeling. Is that 3 gallons? So we're going to take our answer from the last question, which is 715 cubic inches. We're going to multiply it by 1 gallon over 231 inches cubed. Okay, so the inches cubed and the inches cubed cancel, and we get 715 divided by 231. 715 divided by 231 equals 3.095 gallons. Okay, so it says that it is a 3-gallon tank. Is this claim true? Well, 3.095, if we rounded to the nearest gallon, that'd be 3.1, which is less than 3.5, so we would round down, so I would say yes, the claim is true. If they were less than 3 gallons, then I'd have to say no. It's okay to over or underestimate a little. If you say it will hold 3 gallons, but it holds a little bit more, consumers would be happier than if you said it holds 3 gallons, but it holds a little bit less than 3 gallons. B, the pet store recommends filling the tank within 1.5 inches of the top. How many gallons of water will the tank hold if it's filled to the recommended level? Okay, so now we have volume equals length times width times height, or base area times height. I'm just going to show everything here. Volume equals length times width times height. Okay, and we know the volume is 715 cubic inches. So I'm going to put my given in. 715 inches cubed equals, okay, it says how many gallons of water will the tank hold if it is filled to the recommended level. So now we're not going to have 715 in. I need to get rid of that. Put the V back. And we have a length of 11. That won't change. 11 inches. We aren't going to change the length of the tank. The width of the tank is not going to change, which was 6.5 inches. But now the height is going to be 1.5 inches lower. The height of the water, the level of the water is going to be 1.5 inches below this 10 inches. So 10 inches minus 1.5 inches is 8.5 inches. So our new height is going to be 8.5 inches. Okay, so now when I go to do this, okay, bring my calculator in, say 11 times 6.5 times 8.5. And that equals 607.75. Okay, but we don't want to know it in inches cubed. So now we're going to take that 607.75 inches cubed and multiply it by this 1 gallon over 231 inches cubed. Okay, and that is going to equal the inches cubed and the inches cubed cancel. So I take this 607.75 and divide it by 231, and I get 2.63. Okay, so how many gallons of water will the tank hold if it's filled to the recommended level? It will hold 2.63. Okay. Okay, this next question says that Jay wants to cover the back, left, and right side of the tank with a background picture. So you can only look into the tank from the front, probably have rocks or whatever on the bottom, and there will probably be a lid on top. So he's got a background picture across the back and the left and the right side. It says how many square inches will be covered by the picture, and that is surface area, which would equal the length, excuse me for pausing here, I'm trying to think of how to explain this. It'd be the length times the width of the back plus length times the width of the left side plus length times the width of the right side. And the left and right side are the same, so I could have said the surface area equals length times width of the back plus 2 times the length times the width of the sides, because these are the sides. There's 2 of them and they're equal. Now if I go back to my first problem, opening exercise, okay, the back is 11 by 10. So I need to keep going back and looking at these values. So the surface area equals 11 times 10. That's the back. And then we have 2 sides. One side is, both sides are the same, They're 6.5 wide by 10 inches tall. So it's going to be 6.5 times 10. So the surface area is going to equal 110 inches squared plus 2 times 6.5 is 13 times 10 is 130 inches squared. So the surface area is going to equal the sum of these two, which is 240 inches squared. Okay, in this problem it says water in the tank evaporates each day, causing the water level to drop. How many gallons of water have evaporated by the time the water in the tank is 4 inches deep? Assume the tank was filled to within 1.5 inches of the top to start. So what that means is, if we go back to our question where we are filling it to 1.5 inches, okay, then we had 2.63 gallons. Okay, we need to keep that in mind, 2.63 gallons. Okay, so I'm trying to think. Okay, the volume of the water is when it's 4 inches deep would be, so I want the width times this, 11 times 6.5, length times width, and the height is 4. 11 times 6.5 times 4. Okay, length times width times the 4 inches of water. Again, I should be writing inches here, so let me rewrite this. Volume equals 11 inches times 6.5 inches times 4 inches. So the volume equals 6.5 times 4 is 24 plus 2, 26 times 11 is 260 plus 26. 286 inches cubed. Okay, so there's the volume of when the water is only 4 inches deep. If I go back to that last problem where the water was full, it was right here, cubic inches, 607.75. So the difference would be 607.75 inches cubed minus the 286 inches cubed will give us how much water evaporated. Okay, so assume the tank was filled up. Okay, so it says how many gallons of water has evaporated. So you take the full value, the value remaining after it's only 4 inches deep, the difference is what evaporated. So I'm going to take 607.75 minus 286. And it's 321.75 cubic inches evaporated. Okay. Now up comes an exercise. It's your turn. So pause the video, see if you can do this. We'll come back and discuss it. Okay, so it says we have two fish tanks. One is the shape of a right rectangular prism, and one is in the shape of a trapezoidal prism. Tank T, tank R, trapezoid, rectangle, and one in the shape of a right trapezoidal prism. Okay, which tank holds the most water? Let vol R represent volume of the right rectangular prism, and vol T represent the volume of the right trapezoidal prism. Use your answer to fill in the blanks with vol R and vol T. Okay. So I want to find the volume of these. So the volume of the rectangular prism equals length times width times height. So the volume of the rectangular prism equals 25 inches times 10 inches times 15 inches. So the volume of the rectangular prism equals 25 times 10 is 250 times 15. 250 times 15 is 3,750 inches cubed. Okay. So might as well color code this the right way. So I'll make that red. So now I'm going to do tank T. So the volume of tank T equals volume of a trapezoidal prism, base 1, plus base 2. So it's the volume of the base area times height. The base area is a trapezoid, and the base of a trapezoid, volume, or the surface area, or the area of a trapezoid, is 1/2 base 1 plus base 2 times its height. So first I need to do this. So it's going to be 1/2, and base 1 is 25, plus base 2, which is right here. So I am told that this is 6. There's my key. So if that's 6 and this is 6, it's 12 longer than the rectangle in the middle, which is 25. 25 plus 12 is 37. And the height of the trapezoid, be careful, is 8 inches. Okay? So the base area equals 1/2. Well, how about I just fix this as I go? I can get rid of that 8 first. 1/2 of 8 is 4. And 25 plus 37 is 62 inches squared is what we're going to come up with, because these were inches and these were inches. So the base area is 4 times 2 is 8, 6 times 4 is 248 inches squared. Okay. So the volume of the trapezoidal prism is 248 inches squared times its height. Now we're talking this height here, which is 15 inches. So when I take the volume of the trapezoid to be 248 times 15, 248 times 15, boom, 3,720 inches cubed. Okay, so 3,750 is greater, so the alligator eats the bigger. Remember that? Okay, but anyway. So, I'm going to put, that's the volume of the, I'm not going to put the amount here because read the directions. Use your answer to fill the blanks with vol R and vol T. Vol R is greater, so I'm going to put the volume of R here, and the volume of T was less, so I'm going to put vol T here. And I've answered the question. Be careful how they word it. Answer them the way they ask. Okay. B. Which tank has the most surface area? Okay. This is going to be a really lengthy lesson. I can see already. We're at 23 minutes only on this. Okay. Which tank has the most surface area? That SA of R represents surface area of right rectangular, SA of T represents surface area of right trapezoidal. Okay. So, we want surface area. Love these questions where I have to keep going back a page to look at. So, surface area, 25 by 15. I'm just going to do it this way. So, surface area of the rectangle equals 25 times 15 plus, so that's the front and back. The bottom and top are 10 by 15. Okay, so 10 times 15. And there's two of them, top and bottom, front and back, plus, and then finally the sides. I have 25 by 15, I have 10 by 15. What am I missing? 10 by 15 and 15 by 25. $15 by 25, 10 by 15. 15 by 25, front back. 10 by 15, left right. top and bottom are 25 by 10. Okay, so 2 times 25 by 10. So the surface area of the rectangle is going to be 25 times 15. I'm doing this a long time. I'm getting numb. 375 times 2. 750. Plus 150 times 2 is 300. Plus 250 times 2 is 500. So the surface area of the rectangular prism is 1,550 inches squared. Okay. Now the trapezoid is going to start with the bottom, and it is 25 plus 12, which was 37 by 15. Surface area of the T equals, this is the bottom, which was 37 times 15, I think I said, plus, so I did 37 by 15, that's correct. And the top is going to be 25 by 15. So this is bottom, so it's top. Plus 2 sides that are equal. And the sides are, okay, so we know this is 6 and we know this is 8, but we don't know that. And we can't get that unless we know the Pythagorean theorem. And it's a 3, 4, 5 right triangle, so to save time, I'm just going to tell you that is 10 inches. 6, 8, 10. Okay, so it's going to be 10 by 15 for the 2 sides. Those are the sides. And then we have front and back. And they're the same, so it's 2 times the front and the back. Hopefully I'm not confusing you with this back and forth stuff. I have no choice. Okay, so we have a trapezoid for the front and back. We already did that base area, which is right here. 1/2, 25 plus 37 times 8. So the surface area of the base was 248 square inches. So that's what I'm going to put here instead. Why do it twice, right? Already answered the question in this assignment, so it's still considered being done. Alright, so 37 times 15. 37 times 15. 555. Plus 25 times 15, which is right here, 750. Plus 150 times 2. Plus 248. So the surface area of the trapezoid is 555 plus 750 plus 300 plus 248. That equals 1,853 inches squared. So the surface area of the trapezoid SAT is greater than the surface area of the rectangle. Okay. And this goes on. I'm going to pause for a minute. Okay, I investigated this problem a little bit, and it says that water evaporates from each aquarium. After the water level has dropped 1/2 inch in each aquarium, how many cubic inches of water are required to fill up each aquarium? Show your work to support your answer. Well, when you're doing math problems that are related and multi-step, oftentimes you've already done work that they're asking for again, and you can just do a minor adjustment to the work you've already done. So if you go back and look at the volume problem that we did here, we found the volume of the whole thing. That's the volume of this one. Here's the volume of this one. What they're saying is the water level drops 1/2 inch in each tank. So if the water level dropped 1/2 inch in each tank, This 15 is now, you guessed it, 14.5 inches. And this 15 is now 14.5. And this 15 inches is now 14.5. So I've just copied all my work over to here. And I am just simply going to change this to 14.5 inches. And I'm going to change this one to 14.5 inches. Okay, so let me get rid of my answers here because they're going to change. But everything else is the same now. So let me get my calculator. And now I'm going to take 25 times 10 times 14.5. And that is 3,625 cubic inches. Now I'm going to open my calculator back up, move it over here so I can see this problem, and I'm going to take 248 times 14.5. That's 3,596 cubic inches after the water evaporates. So it says, how many cubic inches of water required to fill up each aquarium after the water level has dropped? So I haven't answered the question. It says how many cubic inches of water are required to fill each aquarium. Okay. So my original, shouldn't have erased that, I should have written next to it. My original volume was 3,750. And now it's 3,625. So it's 3,750 cubic inches minus 3,625 cubic inches. And that is going to be 75 inches cubed for the rectangle. This one, right? 3,750 minus 625 is 125 inches cubed. If I go back and look at the volume of my original trapezoidal tank, it was 3,720. So I'm going to now take 3,720 inches cubed and subtract 3,596 inches cubed from it. And we're going to get 2 to 1, 10, 4, 7 to 6, 11 minus 9, 2, 6 minus 5, 124 cubic inches. So one's going to be 125, one's going to be 120. So we just learned that for every ½ inch of water, there is 1 cubic inch more in the rectangular prism. Okay, so finally we're at exercise 2. It says to design your own fish tank. Design at least 3 fish tanks that will hold approximately 10 gallons of water. All the tanks should be shaped like right prisms. Make at least one tank have a base that is not a rectangle. For each tank, make a sketch and calculate the volume in gallons to the nearest 100. And these are 3 possible designs that were given in the book. So they drew a little diagram. A rectangular prism, 24 by 8 by 12. A triangular prism, that was the base was 20 by 16, and it was a triangle, and the height of 14. And then a hexagonal prism, 6-sided figure, that was with the given dimensions, and these were the solutions that they came up with. So if you feel the need to look at that and see if you could do these, what I would say is pause the video right now, see if you could find it with these given values, and then check your work. And then come back, and these are the answers. Okay, see how you can make lesson 25 challenge. Okay. I'm not going to do this challenge part. I think it is on the last page anyway. I think I brought it in on the last page. Yeah, the challenge is right here. Okay, So here the challenge says each tank is constructed. So here's the answer to the challenge. So spoiler alert, if you want to do that challenge, the answer's there. And that is the end of lesson 25. Woo, 35 minutes. Woo. All right. Go do your problem sets.